All right, folks, welcome. Welcome to How to AI Almost Anything. So we're very excited to offer this course for the first time, as is Media Lab tradition, following the courses on how to make and how to grow almost anything comes this third edition of How to AI Almost Anything. We're really excited to be your teaching team this semester. If you don't know me, my name is Paul. I'm a new faculty at the MIT Media Lab and MIT EECS. I direct the Multisensory Intelligence Research Group. And alongside myself, we have two fantastic TAs for my students, Shanaka and David, who will be helping out with some of the assignments and supervising some of the course research projects. As I mentioned, we're all part of this broader group called Multisensory Intelligence, a new research group at the MIT Media Lab. Our research focuses on building AI systems that are actually able to take in anything in the world. We call that this next generation of AI systems that are multisensory in nature. Beyond understanding language, to vision, gestures, and various sensors in the world. And therefore, a lot of focus of this course will be about how we can design AI systems that are truly multisensory and take in almost any sensory modality in the world. We also build systems that actually help the human experiences, not just AI systems that replicate or duplicate what humans can do, but how can they actually help humans to lead to better collective outcomes? And that'll be a focus of this course as well. And finally, because we're all seeing AI systems that are very closely, very powerfully in understanding and interacting with humans, it's also really important that we make sure that they're safe for reward interaction. So towards the end of the course, we'll cover different parts of how we can make these AI systems truly safe and robust. So AI for anything. The whole world around us is multisensory, and we have started to see a glimpse of AI systems that are able to start processing and interacting with more and more of these mediums in the world. We have seen AI, large language models, for spoken words or typed text on a computer. We started seeing systems that can understand our speech and our vocal expressions. They can understand our facial gestures and body language to holistically understand how we communicate with other people. We've seen tons of progress for AI in healthcare. These AI systems are able to make reasonable predictions on X-ray images to help doctors in their final prognosis of a patient. They can also be used to understand different cells, various forms of medical sensors, and that's just the tip of the iceberg. We've seen AI literally applied to almost all of these modalities in the world. So it's really exciting times, and I want to start with some of my favorite motivating examples of AI for anything. AI has really made its way into physical sensing. So in robots, for example, that requires understanding force and tactile information. So that allows robot arms to feel whether they're grasping a hard or soft object. They can feel where they're supposed to put this object into and whether that's the right position. And at the same time, most of these robots also have cameras on them, scanning you various shapes, colors, sizes, and things in the environment. And the more sensors that you put on these robots, the more robust. You can start pushing these robot arms to messing up the force, to simulate an earthquake, for example, and they can rely on vision to solve the task. Likewise, you can start occluding some of these robots' cameras with a folder to simulate rain or fog. You can then rely on force to solve the task. Some of the cool things that's also happening in our group include building AI for smell. So here's a chip that is able to sense volatile gases that are released by different foods and beverages. So that's a different type of sensory modality. You can train AI systems after you've collected enough data to essentially detect the so-called smells of different foods and beverages. So over here in this video, this chip is programmed to smell the presence of peanuts. So you can bring it to a candy bar or a piece of cake or a jar of peanut butter, and it will detect peanuts if it's present. That can be very useful for someone who might be allergic to peanuts. Of course, in this course, we're also going to cover generative AI. Generative AI that are able to take in any modality and semantically translate it to some other modality of interest. For example, typing in a text and coming up with a video corresponding to that input caption. Given a video, generating an audio clip that corresponds to that video. For example, choosing the right music or soundtrack to go with the video. So we'll cover these generative models that are able to translate from any modality to the other. We're going to cover examples of applying AI for all these holistic indicators of health. And a lot of these holistic indicators of health are not going to be taken in the doctor's office. Right? We go to the doctor maybe once or twice a year, but there's so many ways that we can sense our daily health and wellness on a day-to-day basis. So for example, in the area of physical health, there's opportunity for building AI that can really at a high resolution understand the status of patients in the ICU, whether these patients are sitting up, falling down, whether they need help from doctors and nurses. And you can relay that information in the context of emergencies to these doctors. In the area of emotional well-being, there's an increasing amount of sensors that are on our bodies, on our mobile phones, that can sense various aspects of our mood, stress, and emotion. And finally, there are aspects of AI that can be used to understand how will we interact socially with other people through the exact verbal words that we say, but also using any nonverbal expressions or gestures that we use to communicate in groups. And finally, everything that we've discussed so far has mostly been in perception. So given some data modality in the world, can I predict something? There's also a new generation of AI that's emerging that's about interactive agents that go beyond making a single step prediction to taking multiple actions to solve tasks for humans. So some of you might have seen these agents for the web, where you might be giving them some natural language instruction. For example, go to Amazon and purchase from me a set of earphones with this color and at least 4.5 stars in rating. And these agents can then understand this instruction and essentially execute a sequence of actions. For example, Googling and typing for the word, the keyword search for earphones, sorting by the rating, choosing a color based on previous purchasing preferences, adding it to your cart, and checking out. This is new generation of agents that are interactive. And this has enabled a new generation of these agents interacting with humans. For example, they can understand instructions that the humans give. They can be grounded in various digital mediums. We've seen these agents on websites. Very soon, and perhaps even already, we can also build agents that can help you manipulate PowerPoint and spreadsheets. And eventually, we're going to see agents for a multitude of computer tasks help you. So that's a quick glimpse of the opportunities for building an AI for anything, going from understanding of physical environments to being able to process and generate various digital mediums on the internet, being able to understand holistic indicators of health and wellness, and finally, interactive agents that doesn't just make a prediction, but can do tasks for us and improve our productivity in our day-to-day lives. So hopefully all of you will learn something from this course, right? The whole goal of the course is to teach the principles of applying AI for any modality, especially new modalities that are not really at the forefront of AI research. And when I say principles, I really mean being able to think intuitively about what kind of data you need and where you will collect that data from, what kind of model architectures you would need and how you design those model architectures. How would you quickly experiment and evaluate the success of your models on your data? And what are the real world concerns that you got to tackle before you can actually deploy such an AI system in practice? So it's going to be quite different from traditional introduction to machine learning and introduction to AI courses, because over there, the focus is primarily on the models, right? You have 15 weeks of lecture. Each week, you learn about a different algorithm one by one. Rather here, we're trying to teach you the principles, not the methods themselves, but the principles of how to think about what data is useful and how to collect it, various forms of modeling architectures, and all these iterative evaluation and deployment pipelines that you're going to take care of after you've designed your initial model. I've put some examples over here. Clearly, a lot of people are interested in gestures, medical data, lots of interest in physiological sensors and wearable sensors, mobile data. I don't think people mentioned social networks. That's also another pretty understudied area of AI. So that's the first theme of the course, AI for new modality. Naturally, the second theme of the course is going to be about multimodal AI. There's many applications that people have mentioned where you have to connect different data modalities together. So for example, you might want to connect language and gestures to holistically understand a person and their social interactions. You might have to connect sensing and actuation and have a loop that senses and takes actions and senses and takes actions in multiple times. So we're also going to cover elements of multimodal AI How do you conceptually build data that enables you to learn the connections between modalities? How you build the model architectures to learn these connections between modalities, and how you would evaluate and deploy these systems in practice. So that's an overview of the course. There's several learning objectives that I want to highlight. It's going to be half lectures and half independent research and discussions. So the goal in the readings is to really study recent technical achievements in AI research. This will be communicated through lectures, but also individual paper readings and critiques of these papers. By reading these papers, the goal is also for you to improve your critical reading and critical thinking skills. Another big goal of the course is for you to not just understand what exists so far, but also how to project and understand future challenges, future visions of what AI might be able to achieve and how we can make those achievements. And finally, there's a big hands-on component where we would explore and implement some of these new research ideas and go towards that future. Logistically, several prerequisites. Preferred prerequisites. So don't worry if you don't satisfy any of them. We'll try to tailor the experience of the course depending on what you know or not. But ideally, that you have some knowledge of programming, ideally in Python, although you should be able to pick up Python if you program in some other language, because most of these AI toolkits and implementation will be done in Python. Ideally, you have some basic understanding of modern AI capabilities and limitations. So basic understanding. You don't need to dive into the technical and mathematical details, but you should be able to know what are some of the latest advances, what are the capabilities, and what are the limitations. Scrolling Twitter every day is a good way of achieving that prerequisite. Ideally, you will bring some external non-AI domain knowledge into this course. And from what everybody has described, we have a ton of that. Right? It'd be great to bring some external knowledge about some sensor or some task or some domain or problem that you're working with, and collaboratively find solutions to tackle those domains. And as a bonus, it'd be great if you experienced or tried or prototyped some AI for some modality, and maybe you could take it a next step further to really dive deeper into the research questions. Okay. So the course delivery format is that we meet twice a week on Tuesdays and Thursdays, 1 to 2 p.m. over here. Tuesdays will primarily be 1 hour of lectures from usually myself or maybe some of my students and other guest lectures. And Thursday is going to be more hands-on and more interactive. So that will be a mix of either readings done before the class in which we bring them in and we discuss some controversial topic about those readings in class. Or it could also be some tutorial that is getting people hands-on experience to work on some code or implementation. The reading assignments will also be given outside of class. There's several reading assignments that you have to read in preparation for several of Thursday's discussions. And finally, there's also a very significant research component that is expected to be done throughout the course of this project. And ideally, this research component would synergize with the current domains and modalities and tasks that everybody is already interested in and working on. Would someone mind closing the door? Thank you. Okay. So let me just first cover quickly the lecture topics. There's going to be 4 main modules in this course, each lasting about 3 to 4 weeks. The first module will cover the foundations of AI. So in today's lecture, we're giving an introduction to AI and also the logistics of the course. In Thursday's lecture, as an exception, there'll be a lecture this Thursday. We're going to cover the basics of doing AI research. Everything from doing literature review and reading papers, to coming up with good research ideas in AI, to quickly experimenting with them and verifying them, to writing a paper and publishing the results. So week 1 is going to be just introduction to AI and AI research. In the next 3 weeks, we're going to cover the principles of how we can apply AI to anything. And as I mentioned, these principles are going to cover 3 parts. Firstly, how do you think about data? What are some properties of data that ideally you would want to model using some AI system? We're also going to cover different forms of data, how you can collect this data from either the internet or the world. Following that, after discussing these principles of data, we're going to cover several common model architectures. And again, the goal is not to cover all of them in detail like you would in an AI course, but it's really about teaching the general principles so that you can then design some new architecture that is suitable for your data. So most likely these architectures are not just going to be vanilla architectures that already exist. There's probably going to be some adaptation needed to get it working for your data. That's going to be week 3, covering models and architectures. And week 4 is going to cover learning and generalization. Once you obtain a data, you're going to define some model that you would train on the data. How do you actually train it? There has to be some training function. So I'm going to cover different examples of training functions. How do you monitor the learning process to make sure that your models are actually learning? And how do you choose the right models that would then generalize and work in the real world when you have new data? So at a high level, I'm going to cover the foundations of AI in the first 4 weeks. Module 2 is going to be the foundations of multimodal AI. Now, oftentimes you have multiple sensors or multiple data modalities that need to be connected to each other. So we're going to cover different reasons why modalities are connected and ways of learning these connections using machine learning. We're going to cover different ways modalities interact with each other to give new information and learn this new information through fusion methods. And finally, we're going to cover cross-modal transfer. This idea that you might have limited data in the modality that you care about. How do you find something else to supplement and improve the learning process so you do better than the limited data that you only have? Just nice, we have spring break, marks the midpoint of the semester. And when we come back from spring break, we're going to cover large models and modern AI. So everybody's going to be excited by this theme. We're going to have several lectures on the key elements of how people currently do pre-training, scaling, and fine-tuning these large language models, with a bigger focus on fine-tuning, because I don't expect anybody to be doing pre-training of LLMs, but there's many applications in which you want to fine-tune them to your settings. What are the best practices for fine-tuning them to your particular domain? We're going to skip class for Members Week, and we're going to come back and look at large multimodal models, large vision language models, video language models, LLMs plus more modalities. And again, we're going to cover how we can quickly deploy and adapt these large language models to your modalities of interest, which may not be language, which oftentimes is not going to be language. And finally, we're going to cover modern generative AI, systems that don't just make a prediction or output text, but can actually generate more data. So generating images, maybe generating sensor data, generating videos, music, art, and so on. Modern generative AI. And finally, the 4th theme will be on interactive AI. How do you build systems that can interact through multiple steps with humans in the loop? So we're going to start that module by first looking at AI systems capable of multi-step reasoning. So complex problems like mathematical problems or reasoning problems that require you to take multiple steps of actions before you achieve the final target. We'll then cover elements of interactive and embodied tangible AI. How do we build some of these AI systems that can actually work in the real world, that have a physical manifestation and embodiment in the real world? And finally, in the last week, we'll cover elements of human AI interaction where there's humans in the loop, in which safety and other concerns will be very important. Okay, so about 12, 13 lectures spread out across 4 modules. Okay, so now grading overview. 40% of the grade would be assigned on reading assignments. So there's going to be several assignments where we're going to distribute several papers. You have to read them. You have to take what you read and bring it to class on Thursdays and discuss in groups, sharing different opinions about critiquing these papers. That's going to be roughly 40%. I'm going to cover more details soon. And 60% of the grade, you're expected to do a high-quality research project with several checkpoints. Proposal with reviewing the literature, understanding the problem, a midterm with implementations of your ideas, and a final report, more implementation and more error analysis of your ideas. Roughly 40% readings and discussions, and 60% course research project. So in more detail, there's going to be 7 reading assignments. They're going to be roughly spread out across the semester, not every week. And in each of these reading assignments, we're going to assign roughly 2 papers. They are required, and about 5 to 6 optional papers, with a number of optional papers. And together with these papers, we're also going to assign several discussion probes. These are probes that test your understanding of these papers by themselves and also how these papers fit into this broader context of some research area. So there's going to be 3 main assignment parts that are meant to be done individually that are due kind of the weekend before the discussion. These 3 main assignment parts are going to be done individually. You're supposed to read the papers. You're going to summarize some notes from these papers. You're going to look for several other papers that are also related in this broad field. And you're going to take a first stab at answering some of these discussion questions by yourselves. And think of it as general reading the papers in depth, understanding them and critiquing them using some discussion probes that we have provided. So all this is meant to be done independently in the week before the discussion. The discussion will be done on Thursdays, during Thursday's class. There's going to be a joint portion where everybody meets over here, and for 15 minutes, several leaders, which I will describe soon, will make a short presentation about summarizing those papers, maybe answering the clarification questions students have about the papers, and also summarizing the papers that other students have scouted that are related to this research area. And the joint portion, mostly students presenting. There's going to be a separate session, which is going to be some number of discussion groups. I'm trying to keep the discussion groups to about 10 students per group. So the number of groups will depend on how many students finally enroll in the class. And for about 40 minutes, we're going to essentially have roundtable discussions, back and forth discussions, each student voicing some opinion about the discussion probes, and other students either agreeing or disagreeing with it. And there's going to be several note takers which summarize the outcomes of the discussion and writes it out in a coherent report. So that's going to happen on Thursdays. So there's several discussion roles. The first role is that of a reading lead. So there's probably going to be 1 or 2 reading leads per week. These reading leads are in charge of the short presentation at the beginning of Thursday's class. So they prepare a short presentation, summarizing the papers, answering clarification questions, and also summarizing other resources students have found that are relevant to that week's topic. And they also help with note-taking during discussions. The other role is the synopsis lead. They will first help with note-taking during the discussion, but their bigger job is to summarize everything that has happened in the discussion, all the back and forth conversations into a coherent report that is going to be publicly released and shared with the entire class. There's going to be 1 of these per discussion week. Reading leads do most of the work before the class and present at the beginning, and synopsis leads do most of the work after the class. So they summarize and write out this coherent report summarizing the discussion. So it's going to be one of each, maybe 1 or 2 per each of these roles every week. So here are some of the discussion topics. Not going to have discussion for the first 3 weeks. That's more meant for introduction to the course. But we're going to start by discussing properties of learning and generalization. So what are different ways that we can make sure our models learn smoothly? What are different ways of selecting the right model? And what are different ways of assessing how well our models generalize to new unseen data that you want to actually test it on in the world? We're going to have a pretty controversial topic, in my opinion, on whether it's better to build specialized or general model architectures, right? Most of machine learning started off specialized. You would have a problem, you would design a very specific model to your problem, but nowadays we see the trend of building general purpose large models that are applicable to everything. What are the pros and cons, trade-offs? How do we balance both? We have a discussion on cross-modal transfer. We're going to listen to all of your thoughts on the current modality that you have of interest. Probably not going to have that much data, for example, medical or sensor data. What are ways that we can find different data resources and put them to help you solve your task of interest? We're going to have several discussions around reading these latest papers on large language models and large multimodal models, these long reports, and discussing various aspects of them, how they train, how they scale, and how they can be fine-tuned and deployed for different instances. And finally, we're going to have discussions on generative models and human AI interaction. Okay, so 7 discussion topics, roughly spread out throughout the semester. So again, just quickly, all this is provided online, but there's going to be a grading scheme. Recall that all the readings and discussions add up to 40% of your grade. So 15% of the grade would be done individually, reading the papers, filling out some forms, answering the questions. This is breakdown you can read by yourself. 15% of the grade is going to be on the day of Thursday discussing. So just to make sure everybody's voicing their thoughts, you're supposed to say something independent and also reply to other people when they share their thoughts. So that's going to be 15% of the grade participating in the discussions. And that's 30%. So the last 10% would be for the special leads, the special leads for that week. The reading lead who does more work before the class, preparing that initial presentation, and the synopsis lead who does more work after the class, summarizing the discussion and writing out a coherent report. Okay, so 40% total for readings and discussions. We're also gonna, TBD, depending on how the discussion goes, we may also experiment with other roles. This is something that I really enjoy doing. But the several discussion roles include, for example, a peer reviewer. You might assign a paper, and one of the roles might be a student is expected to pretend they're a peer reviewer and really review this paper coherently, right? What are its strengths, what are its weaknesses, how it can be improved, whether there's any experimental or mathematical errors in the paper. That's one role we experiment with. Another cool role we might experiment with is this archaeologist, who a student might pretend that they found this paper in the past. So how do you, for example, contextualize a paper in the context of some of the more recent advances that have happened? The recent work become inspired by that paper, or the recent work disprove that paper, and so on. There's an archaeologist tracing the history of that paper. An academic researcher, you're going to pretend that you are someone who works in that area. You've read this paper. How do you generate new ideas based on top of that? Coming up with new research visions and directions on top of that. Industry practitioner, we're going to pretend that you're head of research at a big company and you're trying to convince your boss why this paper is going to make a lot of money for the company. Hacker, someone who has to build something quickly, a system quickly. How can you read the paper and come up with a quick and dirty demo implementing that paper and what you learn from actually implementing and demoing it? And finally, a private investigator. How do you, a role where you're trying to trace why the authors of that paper worked on this paper in the first place? What were their backgrounds? How did they get inspired by that idea? How they might have done things differently if they had a chance to redo it? And finally, social impact. Assess how this paper either makes positive or negative social impact on the world. Okay, so some interesting discussion roles. You might play around with this. I don't expect to have all of these on every Thursday, but we'll play around with it to maybe simulate the discussion. Okay, so summarize. For a typical week, for those 7 reading assignments, again, not every week, usually the previous Wednesday, the reading assignment will be released with the 2 required and several optional papers. We're also going to give several discussion probes and assign the roles. You're going to first individually read those papers over Wednesday, Thursday, Friday, the weekend, and submit the individual reading assignment on Monday. So just your personal reflections, answering those questions. The reading leads will then spend Monday to Wednesday preparing their slides, answering clarification questions, and summarizing the resources that students have found. On Thursday, we're all going to meet in class. The reading leads first present. We're going to discuss in several groups, depending on how many students. The synopsis and reading leads will take notes. And the synopsis leads will then summarize the notes and come up with a coherent report, which they will then share with their class. Okay. So that's about 40% of a grade, a typical week with these readings and discussions. Any questions so far? Okay. I'm going to send out a poll for people to choose which weeks they like to take the lead on. When we send out that poll, look at which topics you're most interested in and also book out any weeks in which you might not be available due to travel or conferences. Okay, so that's 40% of the grade. The other 60% of the grade, you're expected to do a high quality research project. This project will be similar in spirit to an independent study project. We're expected to do these project teams ideally in groups, but if there's a reason in which you want to do it by yourself, we're also open to that. Of course, it can share some commonalities to the research that you're currently doing as part of your master's or PhD research, but it should not be a perfect duplicate. So for those which seem similar, we're going to try to find a way such that it's not exactly the same and double count it for both research and this course. The final report should be like a high quality AI research paper, and you're expected to really go out and explore new ideas instead of just implementing what is already out there. Okay, so several research ideas that I think people might be interested in. These are just themes. Of course, you're free to propose your own ones. I mean, a lot of you are working on new modalities, right? How do you build these AI systems that are currently mostly for language, vision, audio, and adapt them to these new modalities? Whether it's a data challenge, either collecting data, annotating it, or a model architecture challenge, or coming up with the right evaluation frameworks for your new modalities. These are all potential research directions. Some things are really interesting in particular. For example, deep learning has not found to be very effective for time series and physiological sensors and tabular data. Most of these traditional methods like gradient boosting still work really well. How do we reconcile this? It would also be great if some people were interested in, for example, taste, art, music, smell, taste, art, music, and tangible embodied systems. These are all great directions for research. Also, big challenges in AI reasoning. I think that is the hot topic nowadays. How do we get AI systems to actually reason robustly across multiple steps for these challenging problems, like mathematical reasoning, logical reasoning, building agentic systems that require you to interact over multiple steps. And that's a general direction. Interactive agents as well. A lot of you have mentioned problems that are mostly of a predictive nature, but how do you extend it to the next level where you make a prediction that actually can help control a system? For example, you might want to understand a sensor the person is wearing, not just send something from the person, but also maybe take actions to regulate the person so that some notion of well-being is maximized. So that requires you to build systems that both sense and take actions. Research on building AI that is more embodied and tangible. So coming up with a physical medium so that you can deploy these systems, in which case a core research question is how do you, for example, get those AI systems to run quickly on the device? There's going to be physical constraints on these real-world systems. Socially intelligent AI, how do you build AI systems that can really understand human social interactions through different mediums of communication? How do you build systems that can understand social relationships, things that you can't just infer from 10 seconds of a video speaking, but might require months or years of data interacting with a person. And finally, for second to last, human AI interaction. How can we build new mediums for human AI interaction? Most of these AI systems are simply on your computer. What are some other places or mediums that we can put AI on so that it's more interactive, it's more intuitive for a human to interact? How do you build systems that can better convey uncertainty so that humans can trust these systems more? How do you build systems that can ask humans for clarifications so that humans feel that they have the agency, that they're not just in the background where the AI system is controlling them? And finally, new tasks beyond just imitating humans, right? Most of AI today is about some benchmark where you get humans to annotate a measure of human capabilities and use AI to mimic how humans do. How can you come up with new tasks where humans themselves cannot even accomplish, leading to true collaboration? And finally, research projects on ethics and safety. We know these systems are great, but they also have a lot of limitations in either not being controllable or emitting unsafe text or generating dangerous images. How do you come up with a taxonomy of all these types of safety concerns and perhaps come up with new data or training objectives to make sure they are more safe when deployed in the world? Okay, so a bunch of research questions. Thursday's lecture is going to be Introduction to AI Research, where we'll cover all of this and cover more tips for coming up with research ideas. But just to complete some of the logistics, the TAs and myself are really committed to helping you come up with a successful research project. And therefore, there's going to be required bi-weekly meetings with us. about 20-30 minutes per meeting after Thursday's class. So during Thursday afternoon, you're going to be assigned a primary mentor, either myself or the TAs. And you're also supposed to prepare for these meetings by updating a common Google slide or Google Doc showing your progress, but also more importantly, what things that you're stuck with, right? Things that we can help with to debug, to try to think of how we can improve the system. Okay, so bi-weekly meetings. Here's a rough schedule of the bi-weekly meetings together with the key checkpoints in bold. So week 1 is this week. Week 2, there's going to be a pre-proposal where you have to submit at least just like a short Google form with your name, any group members that you want to work with, or if you feel strongly to work alone, a 1-2 sentence description of the modalities and tasks that you want to work on. So that's gonna be week 2. Week 3, all the groups will present their proposals. So by then you are kind of expected to have read the literature within the field that you want to study, taxonomize the state of the art, and outline some of the challenges in the state of the art that you will subsequently want to tackle. That's gonna be week 3, presenting. Week 4 will be the report version of that. 2 weeks later, by week 6, we're expected to have some initial implementation of the ideas that you've come up with. And again, between week 4 and week 6, we'll give you feedback on your proposal to make sure that the ideas you've come up with are reasonable. So week 6, ideally you have some initial implementation of your ideas. After you come back from spring break, the midterm report will be due. That should have a first round of results with your new ideas. And we'll also present those in class, again, to get more feedback from the instructors and your peers. By week 11, you should have updated results. You should have fixed whatever wasn't working in the midterm presentation. By week 13, you should have delved deeper into your method to really understand its successes and limitations, and maybe visualize how the method is working, do user studies to see if it's actually helping the desired goal. And week 14 would be a final presentation in class. And week 16, last week of class, will be when the final report is due. Okay. So rough structure, staggered to make sure that every team is able to complete a final research project by the end of the semester. Right? Yeah, so all this you can just read through by yourself, just the key deadlines between your preference forms, the proposal, midterm, and the final report. Okay, and just lastly, quick logistics about grading the final report. The course project is going to be 60%, 10% for the proposal, 15% midterm, 25% for the final report, and 10% for the bi-weekly updates. So we'll check that you're making reasonable progress in the bi-weekly updates. Right? Everyone is expected to come to class if you decide to officially register for credit. We can also accommodate some number of listeners depending on how many people register. We have to make sure that the discussion groups can actually happen in small groups. So if you're registered, please come Tuesday and Thursday to class. Let us know if you have long period of travel planned ahead so that we can plan accordingly. And there's going to be several wildcards that students can use to extend the deadline by 24 hours. So 2 wildcards for reading assignments. There's just 7 reading assignments in total. So for 2 of them, you can submit them 1 day late. And for the project report wildcards, 2 per team. They can be used to either extend the deadline of your midterm or final report by 1 or 2 days. Okay. And the course website contains all the information. It's also open to the public, so all the lecture slides, videos, and discussion notes summarizing the discussions will all be posted online. And we'll also open up Canvas for the submissions of reading assignments and project reports. Okay, so no assignments this week, no readings. It'd be good to start thinking about what projects you want to work on if you are committed to taking the course for credit or interested in doing the course project, and also maybe finding out teams and partners that share common interests with yourself. So we're going to release a Google form that's going to be due Tuesday next week for project preferences. And this Thursday, we're going to meet here again, 1 to 2 p.m. It's still going to be a lecture on how to do AI research. So we're going to cover how to read papers, how to generate ideas, how to quickly execute research ideas, and how to write and summarize your results. All right? Any questions from everybody?